To interpret this graph, we need to know the difference between the maxima, which is the high point of the graph, and the minima, which is the low points of the graph. The center of the maxima is located at -1 centimeters, and that is the position of the slit relative to the center of the screen. Next, we need to find the distance to the first minima, and that could be found by going to this position 1. You can see that there are 2 centimeters in between the center and the minima. So then we can use that in this equation. We have the distance to the minima, m, which is the amount of slits. So we have 1 for this equation, this situation. Wavelength is not given in this problem, but it can still be used in this formula. D is the distance to the screen, which is given as 6 meters in this problem. And we have W, which is the width of the slit, which is also not given. So we're asked to find the ratio of the width to the wavelength, and we can do that by rearranging this equation to have md over y. And so as discussed in this equation, we're going to use 1 for m as it's a single slit, and 6.0 for the distance to the screen, which is given in the problem, and the 2 centimeters, which is found using the graph to find the distance to the minima on each side. We converted the 2 centimeters to meters to be 0.02 meters, and then we just plug into the equation. We get 1 times 6.0 meters divided by 0.02 meters for a ratio of 300.